Alright, welcome back, my friends, to the show that never ends. Come inside, come inside. Let's do a little multiply monomials here. Alright, so yesterday we took a look at a lesson that dealt with dealing with exponents. And today we're going to take that to the next level. We're going to talk about multiply monomials. And then each day we're going to progress on that and get a little bit more complicated as we go. Okay, but the first thing I want to do is in your notebooks, I want you to start a new page and just take a couple minutes here, probably less than a minute, and just copy what I have down in this picture. It may come to help you later on in this lesson or maybe our future lesson. It's just looking at 2 with different exponents, 3 with different exponents, and 4 with different exponents. So go ahead and take your time and copy this down in your notebook. And then hit play when you're ready to begin. Okay, so now that that's done, let's go ahead on with the lesson here. So let's take a look at this first problem. Now again, you don't need to really copy this down in your notes. I just want you to pay attention to this first example so you can kind of see what's going on. So if you notice in the first problem we have here, we have 3 to the 5th power times 3 to the 7th power. And what we learned from yesterday is just basically rising a number to an exponent is just that repetitive multiplication. So you can see here I've got the first example here, 3 to the 5th, which goes along with 3 times 3 times 3 times 3 times 3, or another way of saying that is 5 times. So I'm just going to write 5 times underneath that, times 3 times 3 times 3 times 3 times 3 times 3 times 3, and the amount of times I wrote that was 7 times. So this is just kind of building upon the lesson that we learned yesterday. So here I have 5 times 3, 5 times 3, 5 times I guess you could say here, and then 3 times itself 7 times. So if we were to kind of put that all together, because it is multiplication, and since it is multiplication, I can kind of squeeze all these multiplication problems together and combine it under one parentheses. And in that parentheses would be 3 times 3 all squeezed together, as you can see here. So what it really is happening here is 5 plus 7 times. So I'm just combining the 5 times and the 7 times to make really one big problem there. So in the way I would write that, to simplify this, is I would come up here to the problem, and I would simply write this as 3, which is our base, and our exponent here would be the 5 times plus the 7 times. Okay? So one thing I do want you to notice is that we are multiplying numbers with the same base. Okay, it's important to note that both of these have the same base, the base of 3, and therefore I can add these exponents. Now, this would all simplify to the following, 3 to the 12th. But for today's purposes, I'm just going to leave that as 5 plus 7, just to kind of emphasize the fact that we are adding our exponents. Now, one of the ways that we can summarize this, or kind of put this in algebraic terms, is if I have 2 numbers, we'll call them x times x. We'll say x to the m times x to the n. Well, based on what we just did, because both of these variables have the same base, they're both base of x, we could just simply add their exponents. So this would then become x m plus n. Okay? So, in your notebooks, I'd like you to quickly jot down the following. Let me just erase this real quick. Then we'll do a couple examples in your notebook so you have. This was probably an easier way to do that, but I'll take the long way today. Why not? Okay? So the first thing I want you to write in your notebooks is the following. Just write down exactly what we just talked about. X to the m times x to the n equals xm plus n. Okay, so let's just take a look at a quick couple examples. So if I have 5 squared times 5 to the 4th, again they have the same base, so based on what we see up here, I could just simply write this as 5 with an exponent of 2 plus 4. And again, like we said, that really becomes 5 to the 6th, but we're just going to leave that as 2 plus 4, again, to emphasize the fact that we can add our exponents here. And then take a look at the second example, as we learned from yesterday's video. When we have parentheses, we like to keep the parentheses, or if we have negatives, keep the negatives. So this next example, go ahead and write this down. Parentheses, negative 2/3. Oops. 2/3 to the 4th times negative 2/3 to the 5th. Okay, so we have the same base. So what I can just simply do is rewrite the base. So again, we're going to use parentheses because we're dealing with negatives here and fractions. So negative 2/3. And then just simply add your exponents. 4 plus 5. Okay? So let's take a look at a couple of examples that are in your workbook. So go ahead and turn to page, I just lost my page. Turn to page 5 in your notebook. So it should look like the following. And you can see in your little packet that we have our original formula, x to the m times x to the n equals xm plus n. And you can see they're just kind of explaining and showing you how they come up with x to the m plus m down below here. You can take a look at that if you want. But let's go ahead and start exercise 1 here. So I'm just going to do exercise 1 and 5, and then you guys are going to do the rest because I think most of you have probably caught on at this point. So here in exercise 1, we're multiplying 14 to the 23rd times 14 to the 8th. And again, most importantly, they have the same base. So then I can just simply write that as 14, 23 plus 8. And again, just leave that as an addition problem in the exponent. Take a look at exercise 5. Now, just because we're dealing with letters, it's still the same thing. The letters or the variables are the same. It's the same base. It could be symbols. It could be animals. It could be cows, whatever. As long as the base is the same, then we can go ahead and add these exponents. So this one would simply be a to the 23rd plus 8. Okay? So go ahead and do exercise 2 through 8 on your own. Go ahead and hit pause, and when you're done, you can check your answers. Okay, so go ahead and compare your answers to mine. You should have caught on fairly quickly. Exercise 8 is probably the interesting one. You just had to figure out what does x have to be if the exponent sum is 14. Well, 9 plus 5 does in fact give you an exponent sum of 14, so x in that case has to be 5. Okay, let's go ahead and take a look at the next page. So in exercise 9 and 10, it's really just the same thing. It's just now we're just involving more bases. But again, the good news is you'll notice in exercise 9, all the bases are the same. So if all the bases are the same, it really doesn't matter how many of those bases we have. We're just going to continue to add them. So if you look at exercise 9, and just simply rewrite the base, and then rewrite all the exponents as 4 plus 6 plus 13. And eventually that is going to equal 9 to the 23rd power. But again, I'm going to leave that showing the addition again, just to really emphasize the fact that we're multiplying the same base, we're adding our exponents. So take a look at exercise 10. Exercise 10 here is going to be the base of 2. And then just simply add up all the exponents. 3 plus 5 plus 7 plus 9. Okay, and you can go ahead and add those up on your own if you want, but I'm going to leave that as an addition problem. Okay, so now in the following exercises, here's where our original notes of the day are going to come back and help us. Okay, so let me just make this a little bigger here, bring this down. So you'll notice in these problems, the bases are not the same. Some cases that's okay, in some cases it's not. Let's take a look at this first one, exercise 11. So here we have bases of 6 and 4. Okay, well, I can't get a base of 6 and a base of 4 to agree with each other. Okay, I can't work them all the way back down to something where I can get them to be the same base. So it's almost like combining like terms. I can then only add the exponents of the same base. So for example, here I would combine 6 to the 5th times 6 to the 14th times 4 to the 9th times 4 to the 3rd, which ends up being, again, add up the like bases, so that's going to be 6, 5 plus 14 times, 4, 9 plus 3. And that's as far as I can take this one, okay? Again, just you're going to have to combine the like terms. Now, exercise 14 is a little bit different. Take a look at 2 to the 4th and 8 squared. Well, if you look at the little chart to the right, this may be able to help us out here. I know that 8 squared, and this, you should know this from the Pythagorean theorem unit, is actually 64. Well, if you look at the chart over here, you can see that 64 can also be written as 2 to the 6th. So you can see they did that for you. They basically changed 8 squared to 2 to the 6th. So now they do have the same base. I can work 8 backwards down to a base of 2. Okay, sometimes it's easy to tell. Sometimes it's difficult to tell. Hopefully, as you eyeball and you become more comfortable, you'll be able to see the ones that are able to become the same base. So now, in this case, I can take 2 to the 4th times 2 to the 6th, and this just becomes 2 to the 4 plus 6. Okay, so what I'd like you to do is just try exercise 12 and 13 on your own. I will tell you that in 12 and 13, those bases cannot be changed, so you have to do like we did here in problem 11. So go ahead and try 12 and 13 right now. Go ahead and hit pause. Okay, so you can see here you combine the negative 4 bases and you get negative 4 raised to the power 2 plus 3. Combined the 17 bases and you get 5 plus 7. Down here, again, the 15s I'm going to combine together, add those exponents, so it's 2 plus 1. If you don't see an exponent, that means the exponent is 1. So 2 plus 1 times the base of 7, which is 2 plus 4. Okay, now come over here to exercise 15. And again, here they're different bases, but I know 9 and 3 are kind of related. And again, if you look over here at the chart, you can see that 9 is just another way of writing 3 squared. So I can transform 9 into 3 squared. So now I do have the same base, and I can just go ahead and quickly write that as 3 with the exponent of 7 plus 2. Okay, exercise 16. These bases are different. I can't really work 5 and 2 together to get the same base. So in this case, this one just stays 5 to the 4th times 2 to the 11th. There's nothing I can do with these two guys. I can't combine them or simplify them. So this would actually be your final answer. Okay. Let's take a look at number 17. Okay. Number 17, it's again, this is one big multiplication. Some people might freak out because now we got these big numbers or these coefficients out in front. Okay, just multiply your coefficients together. So the first thing I'm going to do is multiply 2 times 17. And 2 times 17 is 34. Now all I do is focus in on my bases, which are my variables. So x to the 3rd times x to the 7th. I'm going to use a dot there instead of an x. Okay, so from what we've just learned previously, I can rewrite this whole thing as 34x and just add those exponents. Okay, and the last problem we're going to take a look at today is exercise 18, and we can kind of use the distribution property here, something we talked about in the fall. So I can do distribute the A to the inside, and distribute it to the A and the B on the inside. So really this just becomes A times A plus A times B. Well, again, like we said in the previous problem, if you don't see an exponent, there really is an exponent. There would be an exponent of 1 and 1. So another way of writing this, because these guys have the same base, I can rewrite this as A with an exponent of 1 plus 1 plus AB. And again, I can't take this any further because they do not have the same base. So I would leave that as this problem. And again, I would simplify this again as A squared plus AB. Okay, so again, just to kind of summarize here, remember when you're multiplying items that have the same base, you go ahead and you can just add the exponents. So again, x to the m times x to the n is really xm plus n. Okay, so your teacher will probably pass out your homework. If you have any questions, feel free to ask. And that is all.